What does the absolute value of x greater than 2 mean? The distance from 0 to some number that x represents is greater than 2 units. So let's look at that. 2 units to the right, 2 units to the left. And I want all numbers that have a greater distance, like 3, 4. So everything greater than a distance of 2 would be everything on either side, right? That's a greater or a farther distance from 0 on the number line. So this means our solution will be from negative infinity to negative 2. And stop, because this is, blank. There's no shading here. Solution starts up again at 2 until positive infinity. And we connect that together because the solution is all of this and all of this. Just don't repeat anything. Sound familiar? That means we have a union here. So anytime you have a greater than or equal to, we're looking at the union of a distance greater. So everything greater than 2 or everything less than negative 2. So we're going to use that to solve some absolute value inequalities here. Our first example, the absolute value of x plus 2 is greater than 4. So the distance is greater than 4. That means that we have greater than 4, or take what's inside and make that less than negative 4. The union of those will be our solution. So let's go ahead and solve these by just subtracting 2 from both sides of the inequality statement. Then we have x is greater than 2. And x is less than negative 6. So this or that is our solution. So we have a negative 6 and a 2. We want everything greater or to the right of 2, not including because there's no equals to. So don't include that. And then we want everything less than negative 6, but not including negative 6. So this union is our solution from negative infinity to negative 6. Stop. And pick back up again at 2 to positive infinity. There's no repeating of elements, so this is a good union. Theoretically, if a problem said that the absolute value is greater than negative 2, what does that mean? Well, that means the distance from 0 to some number is more than negative 2 units. And so that doesn't make sense for negative 2 up to 0. Nothing makes sense. But doesn't it make sense after 0? Because it says greater, so all distance is greater than negative 2. So a distance of 0 is fine. That would be true. A distance of 1, that would be true. 2, 3, all distances greater would be true. So all of these would be true for that statement. If you put any real number in for the variable here, you'll have a true statement no matter what, because the distance is always greater than a negative number. Always. So our next example, we want to solve this absolute value here. And there's other stuff going on, and we can't solve for the distance until we get that isolated. So let's subtract 11 from both sides of the inequality symbol. So the absolute value of x plus 1 is greater than or equal to negative 2. And we know from what we just talked about what that means. But if you didn't, if you were like, okay, let me solve this. So I've got greater than negative 2, or what's inside is less than or equal to the opposite, so a positive 2. And then solve those resulting equations. So x is greater than or equal to negative 3. And x is less than or equal to 1. So don't forget the or part though. So let's put the -3 and the +1 on the number line. And let's graph those. I'll do different colors so you can see. So greater than or equal to -3 is looking like this. And less than or equal to 1 is looking like this. So what would be the union of those two sets? Well, if you already knew the answer to this based on the fact that this is greater than a negative number, you would see that I want all of the red and I want all of the blue, even the overlap, but don't repeat it. So that's the entire real number line from -infinity to +infinity. This statement is always true, and we can see that from solving those. And number 3, we want to solve the absolute value here. But again, it's not isolated, so I have to isolate it first by adding 8 to both sides so that the absolute value is greater than or equal to 4. So don't get too excited when you first see the problem with a negative sign on the other side of the inequality symbol, because when we isolated the absolute value, it's no longer negative on that side, so don't get too excited. That means the distance is greater than or equal to 4. So the distance is greater than or equal to 4 for that. Or we can take what's inside and make that less than or equal to -4. Both of those have a distance greater than or equal to 4. So then we can solve the resulting equations. We're going to add 3 to both sides of the inequality symbol. So x over 5 is greater than or equal to 7. Or x over 5 is less than or equal to -1. Then just multiply 5 to both sides of the inequality symbol. So that will leave just x on the left side. And for the first one, that's 35. For the second one, that's a -5. Okay. So let me go ahead with the two colors. And we'll put 35 over here. We want everything more than or equal to. So that includes. And for this one, we want -5 over here, and we want everything less than or equal to. So the union of these two sets, I want everything in red, so -infinity to -5, and I want everything in blue. If there's no overlap, then I'm not worried about repeating myself. So that would be the interval for the solution space of this original inequality.